Okay, so last lecture before the spring break. Okay, so I think we'll make it clear. Today, I want to share with you about the midterm survey that we've done. Okay, so on the board is actually I list out the things that I guess most important thing is actually how my teaching is actually provide. It's actually provide you effective prepare this course. Okay, so I think we have almost 90% of students say yes, the way I teach is actually helpful. Okay, so it's actually wonderful to know. And then I ask you a lot of questions, and I pick up the top 4 things that you think I'm doing well. Okay, number 1 is actually respect student. That's great. Yeah, so I want you to actually make sure you know I do respect my student very much. Okay, so early this morning, there's actually a student come to me and says, he raised a hand, but I did not actually call him during the lectures. Okay, and I need to first say sorry to the student, okay, because if I see you, I would definitely actually call you. I would definitely stop. Okay. But you know, once I get old, okay, so I'm 40 something years old. Okay, my eye is actually getting really, really bad. Okay. So if I don't actually see you raise your hand, you just shout it out, I will stop for you. Okay, so don't think that I did not respect you. I do. Okay. If I don't call you, simply because I did not know you actually raise your hand. All right. Second one is actually well prepared. Of course, I've been prepared this one for decades now, right? So third one is interesting student. Yes, I do. Okay, I'm actually interested in like how you do, what you learn actually from this course, right? I really want to know can I actually deliver the important things beyond the knowledge for this course. Okay, so I would say I think the beauty of go to college is that you're going to meet some amazing people who can actually change your life. Okay, which I encountered a lot when I was young. Okay, so if you encounter someone, most likely will be your instructors or your professors doing research. Okay, they can actually say something that's actually out of your imaginations, right? Because they have been seeing a lot. They've been working with the smartest people in the world. Okay, so take their advice. I think it's actually a good thing to do. Okay. Okay, the last one, encourage participation, of course. Okay, if any questions, okay, don't save those things to yourself, okay? Share with us, okay? Of course, there's something that you guys want me to improve, right? The first one, which section one I got a low score out of 7 is the feedback on exams. Okay, so I actually don't know what else I should actually ask you to do. Okay, so I guess I tell you all I know. Right. So the only thing is actually how to actually get more practice with the old exams, right? So in order to do that, I guess the only thing is talk to your senior friends who actually took this course before. Okay, that's how you can actually effectively get the old exam questions, right? Me as an instructor, I cannot just hand you some old exams from my students. Okay. Yeah, I picked a few. That's actually the question I think is actually relevant to this course. And I actually do all those things in the in-person lecture. Okay. But if you have, because the feedback I got is actually somewhat general. Okay. Many students just, okay, provide more examples. But I thought I already provide quite a bit. Yeah, and if you actually finish the example that I provide, you will be fine, actually. Okay. But if you have some other like specific idea that you want me to try, feel free to actually let me know. I'm very open to those suggestions. Okay. Second, still hoping to provide more clear class direction. Okay. I guess that's actually related to actually let you know like what you should actually expect from the beginning of the class, right? So what is actually the things I want you to learn to make those things more clearly. So I think that's actually a great idea, which I will do. Okay, I'll start to practice that today, and we'll see how it goes at the end of the semester. Okay. Next one is actually adjusting pace for 2 students. I think I'm very open to that. Okay. And most of the time, I actually try to judge whether you understand or not by looking at your face. Okay. But once I get older, I feel like the face I can actually recognize is maybe the 5th row at the most. People who sit beyond 5th row, I cannot really see how your face expression. Okay. So if you feel I'm going too fast, just raise your hand, right? And just like, Dr. can you slow down a little bit? I don't really understand these things. Okay. So just let me know. I will slow down for you. Okay. Very last one. Discussion engagement. I kind of don't get exactly what they mean. So if you have a good idea, okay, and I think this is actually more related to like discussions between students. Okay, so remember I say that on the day one, I say it's good to have friends. Okay, they can discuss, right? And then during our lectures, I actually ask a lot of questions, right? And I totally find that you talk to your friends. Okay. So every time we do these point solution questions, okay, you may not know the answer right away, right? But please just discuss with your friends. Okay. And then I don't say you can actually bring up your phone, you cannot bring up anything. I think on the opposite side is okay, do whatever you want, do whatever you can, right? But figure out the answer quickly. Okay, so those are the things that you should really do. Okay, by now you see that in many perspectives, I'm very different from the traditional professor. Okay, I don't really care too much about the traditional framework. Okay, the things I only care is actually, do you actually understand? Do you actually learn? Do you actually improve? Do you grow? Those are the things I care. Okay, so if no matter what you do, you can actually make a concession and just do it. Okay, and I want to emphasize again, we only live once. I treat it as an adult because I believe that you will be responsible for your future. Okay, so do that. That's the only thing I want my students to do that. Okay, so but this is actually the kind of quick summary about the things that I got, okay? And then I also kind of share with you about the things that I'm going to try in the second half of the semester. Okay, so hopefully by the end of the semester, this become my new routine. Then I can actually do all these things in my future teaching. Okay, so let's act a quick summary about the midterm survey. Okay. The other thing I want to make it clear is that I finally finished all the gradings for the partial credit for midterm 1 last night. Okay, so some students actually get a few points, some students actually get nothing. Okay, so what's the things that you should have in mind is that first, you should recognize that the things is called a partial credit. Okay, that means actually you will never get a full credit back. It's a partial credit type thing, right? And that's important because if you already do it right, you got a point already. Okay, the reason we do this is because you make some mistake. Okay, since you already make the mistake, there's no point, there's no reason that I should actually give you a full point back simply because you do the correction. Okay, so that's actually the first things that you should know to be fair. Okay, second, you should notice that in the instruction, I write a lot of things, right? And the reason I write so many is because the student always have misunderstanding what do I mean by calculation errors. Okay, calculation error is not because you put in the wrong number, therefore you cannot get the correct answer. Okay, calculation error means actually you totally know how to solve that problem. You totally have the correct logic flow. Okay, you just somehow in your calculation, apparently you know you input one number wrong, therefore you lead to the incorrect answer. Okay, so when you write how you get your original numbers, you need to be 100% sure that you know where you did wrong. Okay, many students, they don't even know why they get things wrong. And they expect me to actually figure out those calculation errors by myself. Okay, which make my life very, very, very difficult. Okay, so if you make my life difficult, I don't think it's actually very fair that I spend so much time to help you to boost your grade, right? So the person who got the partial credit back, okay, in your original incorrect answer, you must show this correct logic flow. If you don't show any of those things, you're not going to get the partial credit. Okay, for example, the conversion between your KP and KC, right? So we know KP equals to KC times RT to a delta N power. Okay, so if you say, okay, the delta N should be -1, but I put 0, okay, it's because, somehow I don't know why I put 0 over there. But it's just because I put in the wrong number, therefore I don't get the correct answers. Okay. So this kind of questions, this type of mistake won't get any partial credit back because the question is actually testing, do you know how to actually calculate delta N properly? Right? So it's actually either 0 or -1. Okay. So if you consider that it's a calculation error, then you are in big mistake. Okay. That's actually definitely a conceptual type of errors. Okay. So the same concept will apply to all other type of questions that you feel like you deserve partial credit. Okay. So the most accurate description will be that you actually know exactly how to solve that problem. And you exactly know on what number you input incorrectly. Okay. Only under the conditions, I will consider it as a potential calculation error. Then you may actually get the partial credit back. All right. So I hope I make these things more and more clear because some students, they always email me after they see they don't get any point back. Okay, it's not because I'm not being fair, it's really because that the things you make is actually a conceptual error. Okay. So those are for the partial credit, and then the things that I also found out that is I have 530 students in this section. Okay, so if I limit it to the partial credit to 3 questions, I think I'm okay with that. Okay, the time, yes, I need to spend time, but not too crazy. Okay, so spend like 3 nights actually going through all these things. I think it's actually okay. I will do that. With that being said, means actually we are going to do the same thing for your midterm 2 and midterm 3. Okay, we cannot do it for the final exam because I have to determine the grade by certain deadlines, and they won't give you enough time to do any correction. Okay, so we'll do the same thing for your midterm 2 and midterm 3. Okay, so the assignment will pop up. Okay, I probably should set up those assignment much earlier. Okay, so you always, our test is always from Monday to Wednesday. Okay, that means actually on Thursday you'll be able to see your exam. Okay, so and then the things will actually close on the following Tuesday. Okay, so in the future, the deadline for your partial credit for midterm 2 and midterm 3 will be on Monday. So that everybody will make sure you still can have the access to the test question. Okay, so that's that's why you can actually expect for the midterm 2 and midterm 3. Okay, another thing is that spring break is actually coming. Okay, so in the past, midterm 2 is actually the one everybody do the worst. Okay, and the reason is actually very simple because in the buffer system, right, you calculate the concentration of your solution is a little bit more challenging because that involves more steps. Okay, so I know you're going to enjoy your spring break, but since the midterm 2 is actually coming up, okay, so maybe you have a fun time for the first couple of days, but prepare for the midterm 2 a little bit early. Okay, so I suggest the very last 3 days in your spring break, okay, start to actually come back and really immerse in the material that we have. Okay, again, watch the video first. Once you actually understand the video, once you understand the logic in the videos, then start to do some more questions. Okay, so depending on how much we go through today, okay, we may actually finish the very last chapter for midterm 2, which is chapter 15. Okay, chapter 15 calculation is actually much simpler. Question-wise, it's actually much simple. Okay, so with that being said, the most challenging part is actually chapter 14. Okay, titration part. Okay, so that's the part that you need to really spend your time and understand how to do those things. Okay, but that's pretty much it, right? After we come back from the spring break, we are going to do this midterm 2 questions, right? We're going to go through another, I don't know, 15 to 20 questions in the week before your midterm 2. Okay, so make sure you participate as much as you can and understand everything in the in-person lecture. It's the most effective way to get it where you want. All right? Okay, so any questions before we start today's lecture? Okay, so there are actually only 2 more questions. Okay, what we're going to do today is actually to finish our chapter 14. Okay, so I think in the past 2 to 3 lectures, we start to tell you when you have a titrations, right? And then how do you actually determine which zone you are? Okay, you always start from what's your equivalent point, right? And then we do the question to identify where you are. You're in zone 1, zone 2, zone 3, or zone 4. Okay, and then in different zones, okay, after adding certain of the titrant, you also certainly calculate your acid or base concentration because the volume is always changing. Okay, so those are things that we covered in the past. What we're going to do today is actually do one more practice for question number 6 or 5. 6, okay? And then we're going to do one more question about the indicators. Okay, so indicators is actually things that you're going to use when you do your titration experiment, okay, in your Jenkins lab. Okay, so how do you actually choose the indicators? It is actually a very simple rule, right? Okay, so we're going to go through what's the basic principle of that. Okay, and then we'll actually conclude our chapter 14. And after that will be chapter 15. Okay, chapter 15 talk about the solubility of insoluble salt. Okay, and then we're going to tell you how to write those equations. Okay, and then start to discuss. Okay, if you put those insoluble salts in the acidic or basic solution, how will it change its solubility? Okay, and then the other type of question we're going to talk about is that, okay, we're going to talk about if you actually mix two solutions, can you actually predict the precipitation will occur or not? Okay, yeah, and the very last one is actually if you put the insoluble salt with some other soluble salts, but they have common ions, how to actually solve the insoluble salt. Okay, so those are the things we want to actually go through today. Okay, so let's start from the first one. The first one says the pH of 0.5 m acetic acid is 2.52. Calculate change in pH when 1.59 gram of CH3COONA is added into 49.9 milliliters of 0.5 m acetic acid, CH3COOH. Okay. A lot of words, right? So what are the keywords? Good. Okay, so pH, right? pH is actually definitely, every time I say pH, right? It has to be 13 or 14, chapter 13 or chapter 14. Okay. And then if you read these questions, okay, the way I translate this is actually the first sentence tells me what? Acetic acid, right? So the pH of a weak acid is 2.52, right? So that's actually what it really says. Okay. And then it starts to describe something else, right? Calculate change in pH. Change in pH, then you know is delta pH, right? Meaning you want to know the pH of one thing minus pH of another thing, right? That's what it means. Mathematically translating, okay, you must calculate the pH of two solutions. Okay, then compare different two, then you will know the delta pH. Okay. So apparently, one of the solution is this guy, right? Now we want to know what's the other solution. Okay. So if you look at this, then you see it says this and that, right? So you add in a salt into a weak acid. Okay. Then you want to ask yourself, right? So what's this solution? So what solution are you going to have for that? CH3COONA into a solution contains CH3COOH, right? What's inside that container at the end? The buffer. Can you see it is a buffer? Because the first is CH3COONA, right? Remember I said you see a chemical formula contains your 1A or 2A element. Split it out first. Okay, just seeing what remains. The things to remember will be CH3COO minus, right? So you know you're going to have CH3COO minus in your solution. Okay, what kind of solution do you have originally? Is actually CH3COOH, right? Then you can see that this is a conjugated acid and base. Okay, once you have that, then you know you have a buffer, right? Once you have buffer, then you know you calculate the pH using HH equation. Okay. So this guy we know this is actually the meaningful species, right? And then compare this to this. Then you know that this is actually your conjugated acid, this is actually a conjugated base. Okay. Therefore, you know you're going to have a buffer, right? Therefore, you know you use HH equation. pH equals to pKa minus log weak acid over weak base, right? So let's count the things that you have in mind or just up to your shooting path. Okay. So by now, then you should know that the delta pH, right? One of them is a weak acid. One of them is actually your buffer, right? So once you know the pH of your buffer, you already know the pH of your weak acid. Then you can calculate delta pH, and then you can be able to solve this question properly. All right, so that will be actually the logic flow. Okay, so Q, we want to know the delta pH. Okay, meaning the pH of my buffer minus the pH of my weak acid. Okay, data that you have. The pH of your weak acid is equals to 2.52. Okay, and then for the buffer, you know you have this guy, which is actually your A minus, right? You have 1.59 gram. Okay, and then the formula weight of that is equals to 82.03 grams per mole. Okay, for your weak acid here, you have 0.5 m, and then the volume of your solution is 49.9 milliliters, and then the Ka of this weak acid is 1.8 times 10 to the negative 5. Okay, so let's actually all the information that you have. Okay, so plain. Apparently, the things you want to calculate is the pH of your buffer. Okay, it's going to equals to pKa negative log weak acid concentration of your A minus concentration. Okay, so pKa is negative log. Ka is 1.8 times 10 to the negative 5 minus log. Weak acid concentration is actually 0.5, right? That's actually the things that's given. Now you want to actually compute the concentration of your A minus, right? So do you have that? You do not have that directly, right? All you have is actually the mass of your weak base, right? So to calculate the concentration of lead, you need to do this, right? Compute the moles, which is 1.59 divided by the formula weight, 82.23. That's how many moles that you have. Okay. But you also know the molarity, right? So you need to divide that by the volume. Volume is actually 49.9 divided by 1,000. Okay, so this whole things is the things that you need to compute. Okay. So if you do like calculations, okay, the first term will be if you do these calculations using your calculator, you should get a value of 4.7447. The second term will be 0.1096. Okay, so once you do that, you get a pH of 4.6351. Okay, so this is actually the pH of your buffer. Okay. Then you want to calculate the delta pH, right? Which is like the pH of your buffer subtract the pH of your weak acid. Okay, so it will be 4.6351 minus 2.52. Therefore, you can get the delta pH. It's going to equals to 2.12, and that will be the answer. Okay. So let's recap the things really quickly. Okay, so when you do these questions, you should see that you have two solutions. Okay, one is with acid, the other one is actually proper. Okay, so once you know your two solutions, once you know what solution it is, you actually know how to actually calculate pH, right? So for the weak acid, if it doesn't actually tell you the pH directly, you also know how to do that because the photon concentration of a weak acid can be calculated using the square root of Ka times your weak acid concentration, right? Once you get the photon concentration, you can actually do the negative log of that and get your pH already. Okay. The second one is actually the more challenging one, right? You actually calculate pH of the buffer. Okay, so then you actually testing whether you know the HH equation. Okay, so if you know, then the calculation should be actually straightforward too, right? The only thing that may be a little bit confusing is that when you actually write out all the things, okay, make sure you actually do push your calculator properly. Okay, so you make sure you get the correct numbers. Okay, so once you get the pH of two solutions, then calculate differences, then you can get your answer. Okay, so this is the basic logic solving these type of questions. Okay, so all of this we say actually go back time to the most simple questions, right? So every time you read the questions, you must know what kind of solution that you have. Right? Because once you know that, then the corresponding calculation is actually quite straightforward. All right. So this is actually how you solve these questions. The next one. Okay, so he will ask you which indicators will be the best to use for a titration between 0.3 N NH4Cl with 0.3 N KOH. Okay, it gives the Kp of amine. Okay, so the main idea of this indicator problem is that you must choose the indicators. So you see here, there's actually 5 different indicators, right? So you always specify the indicators and then specify when it's going to change its color. Okay, so we tell you the range of the pH, right? So the pH, okay, is indicating the pH of your solution at equivalence point. Okay, so you want to make sure that for a given titration, okay, you must first calculate the pH at equivalence point. Okay, and let pH value must fall within the color change range. Okay, so for example, if you have a pH change at let's say 11, okay, then the alizarin yellow level is the indicator to choose. Okay, let's say you have a pH change at 7, okay, then the second one, the bromo cymo blue will be the one that you can choose. Okay. So now, this is actually a solution that you have, right? 0.3 N NH4Cl and then 0.3 N KOH. Okay. Now, first tell me, what's your titrant? KOH. KOH is a strong base, right? The NLI will be NH4Cl. Okay. So every time you see a 7A group inside your chemical formula, throw it away. Okay, Cl will become Cl minus, right? Therefore, this is equivalent to NH4 plus. Okay. So then you guys should ask yourself, right? NH4 plus is what? Weak acid. Okay, so it's actually a weak acid, right? Therefore, I use Ha to represent it. Okay. So now we know the pH we are talking about is actually at the equivalence points, right? Therefore, you will need to be able to write this weak acid plus your strong base. What are you going to get? Water and weak base, right? Okay. You really need to actually know how to write this equation based on the hydrogen analyte. Okay. So at equivalence point, meaning you have the same amount of weak acid and strong base, right? Meaning you have the same amount of HA and OH minus. Okay. So the strong base will kill all the weak acid. Okay, and they have the same equal amount. That means actually have to consume each other completely, right? So at equivalence point, what's the only remaining thing you're going to get? Just this guy, right? They say you have one in the beginning, right? All this strong base, okay, they cannot tolerate any acid, right? So they're going to consume each other. So you minus one, plus one, plus one. Therefore, we know at equilibrium, you don't have any HA, you don't have any OH minus. All you have is actually water and a bunch of A minus, right? So you know at equivalence point, what kind of solution do you have? A weak-based solution, right? So even without doing any calculation, you should know that your pH has to be higher than 7, right? So that's the kind of things that you must know, okay? So just with that simple idea, okay? You see this too? This is the standard indicators for the things where your pH equivalence point equal to 7. Okay, so this two is actually for the strong acid, strong base type of things. Okay, so you see it's 6 to 8, right? And it's actually your equivalence point, the pH is around the middle point, which is 7. Okay, so this two cannot be your answer, right? Because you know you are going to have a basic solution. pH is going to be around 7. Therefore, the first two cannot be your answer. Okay, even without doing any calculation, just if you have the concept, then you know the first two cannot be the answer. Okay, how about the third one? Okay, now, right, let's actually, if you have a acidic solution at equivalence point, they will be indicated. Okay, now things actually come back to, okay, your answer has to be either D or E, one of them, right? So that's actually the time that you actually need to calculate the pH. Okay, and see whether it's fall within 10 to 12 or 8 to 10. Okay, so now how do you actually do that based on the things that we have? Then you should come back to this. Okay, so doing these simple things again, you know HA is 0.3 N. KOH is 0.3 N. Right? So this will consume each other. Therefore, you know, once you reach equilibrium, the concentration of your A minus will be 0.3 N. Right? So once you know the, hold on. This is actually something that you need to be careful. This is actually a very interesting part, but you are going to see things. Okay. So we know the concentration of your HA is 0.3. the OH minus concentration is actually also 0.3, right? But every time when you write this ice table for the titration, okay, we actually need to use moles, not concentration. Okay, so since the concentration they are the same, okay, that means once they reach equilibrium point, the volume of both solutions will be the same too. Everybody follow what I say? Okay, so the way you calculate this, when you write out this ice table, right, it should be doing this, right? That's how you get the moles. Okay. And you have like much moles here. Okay. The L, that's the volume. L to represent the volume, right? The concentration times the volume makes you mole. Okay. But once you reach that, you know the mole of your A minus. But all what you care about is actually the concentration of your A minus, right? So to calculate that, you know the mole is that much, right? But you think about what the final mole is. 2L, right? It is not 1L, it should be 2L. Everybody follow what I say? Everybody know what is 2L? Because you have the same amount of weak acid and strong base. Then mix together, right? So each of them has a volume of L. Once you mix them together, you have 2L and N. Okay. Therefore, the volume should be this. Therefore, the concentration of your A minus is this. Okay, 0.3 divided by 2. Okay. So once you know this, since it's actually a weak base, right? Therefore, you know you can write this. AB times your A minus concentration. Okay. What's the KB? So this one is actually give you KB of amine, right? The amine is actually the one that you are going to end up with. Okay, therefore you can just put in the KB 1.8 times 10 to the negative 5 times 0.15 to the square root of that. Then you will be able to get a number of 1.64 times 10 to the negative 3. Okay. Then to get the POH, which is negative log of 1.6 times 10 to the negative 3, they'll give you a value of 2.79. Therefore, the pH will equals to 14 minus your POH, 2.79, which give you a value of 11.2. Okay. Therefore, you know at equivalence point, this solution is going to have a pH value of 11.2. Okay. Once you have that in mind, then go back to this. Which one should you select? Because 11.2 is only fall within your option D, right? So D will be your answer. Okay. So these are questions. Okay. If you just have concept, you can easily eliminate some of the choices already. Okay. But when you get down to this situation, it really testing you, so you know how to calculate pH of your solution again. Okay, so the same thing is going to show up over and over and over. Okay, so it's really actually, do you know how to calculate the pH of your solution? Okay, so let's actually how you solve these type of questions. Okay, and any questions for this? Yes. So let's solve the it's 0.3 divided by 2 because it's moles over your volume, right? The total volume now is actually 2L. Because these two solutions with the same volume together, right? So even though the mole you have is actually 0.3 times L, okay, but the volume right now becomes 2L. To calculate your concentration like a mole over your volume, right? So it becomes 0.3 L divided by 2L. The end up with a value of 0.15.
Sorry, how do you know which one is of the titrate?
Yeah, how do you know which one is actually attachment to not analyze? Your typing can only do strong. Yes. Your questions? Okay. Any other questions? Yes.
So whenever we're doing the ice cream to the, it will give us the concentration for the moles. Concentration.
Yeah. So for the titration, okay, specific for the titration, because you actually be counting, there's actually one molecule is going to annihilate another, right? So number matters. Okay. Number is actually extensive property. Okay, meaning it's actually it's different from the concentration. Okay, so don't to count how many of them will actually cancel out each other. Okay, so it has to be the number, not the concentration. Okay. Any other question for this? So we're good? Yeah. If so, let's actually conclude chapter 14. Okay. So we're going to head into the chapter 15 now. Okay, so chapter 15 is actually talking about the solubility of an insoluble salt. Okay. And first, what we need to know is actually how to write out the equilibrium constant for this insoluble salt. Okay. So typically you're going to see a thing called the KSP. Okay. The K, the capital K, again, is our equilibrium constant. Okay. The SP means solubility product. Okay. So just give you a quick examples. Okay, so let's actually what the KSP means. Okay, so on the left-hand side, you will always see a solid. Okay, so those are for the insoluble salt. Okay, and on the right-hand side will be the dissociated form. Okay, and then the KSP, which is actually the solubility product, is basically just equilibrium constant, right? The Ag plus times your Cl minus. You don't put the AgCl concentration inside the equation because it's a pure solid. Okay, so that's actually what I mean by the KSP. The biggest things that you should actually memorize is that whenever you use the KSP constant, okay, you see that Ag plus concentration and Cl minus concentration. Okay, you must use molarity. Okay, and we call that molarity as molar solubility. Okay, so why this is important is because many times this is what was given inside the question. Okay, it gives you the grain solubility. Okay, but the K is always computed using the molar solubility. So if you see the question give you the grain solubility, you must first convert it into the molar solubility. Okay, so the difference between the two is that the grain solubility is equals to your mole solubility, capital N, times the formula weight, okay, of your insoluble salt. Okay, so the unit is going to be different, right? For the molar solubility, the unit will be just the molarity, capital N. Okay, but for the grain solubility, it will be gram per volume. Okay, either gram per milliliter or gram per liter. Okay, If you see that, you know that it's not the number that you can use. You need to first convert into the mole solubility. Okay, so that's actually the number one things that you must know. Okay. So now, the next important thing is that you must, okay, this is actually a thing that you must become a master, okay? You must know how to write out the solubility. Okay. So the simplest case is this. I use this example. Okay, let's say you have AgCl dissolved, okay? And then once you reach equilibrium, okay, it's going to produce S mole of Ag plus and S mole of CO minus. Okay, and the reason I write S and S is because the coefficient is 1:1, right? If you have one AgCl dissolved, it produces one Ag plus and one CO minus. Therefore, concentration of Ag plus and CO minus, they will be the same, right? So that means your KSP is simple. It will be just S squared, right? However, the things that got more complicated, the things that confuse student is that, example like this. Okay, so if you have an insoluble salt, once you dissociate, okay, it produces the anions or cations not in 1:1 ratio. That's the things become more interesting or more challenging for the student, because when you write out your solubility of this guy, you should know that it should be 2S. That should be S, right? Because the ratio is 1:2. Therefore, I put 2 here, and this is actually 1:1. Therefore, I put 1 here. Okay. To write down. Okay, so if you can actually write this down yourself, then you are in good hands. Okay. Anybody know what I put 2S over there? Yeah, Ag plus. Okay. When I say solubility, okay, I don't think about this very deep. When I say solubility is solubility of who? Solubility of Ag plus CO minus or Ag plus CrO7 2 minus or Ag2 CrO7. Yes, is that insoluble salt? Okay, it's the solubility of that insoluble salt. Okay, so let me say that guy, the Ag2CrO7, is the one we are talking about. Okay, so solubility of that guy, meaning certain concentration of that guy is going to be dissociated, right? And then we call the solubility of that is S, right? And then because one of that, once it dissociates, it's going to produce two equivalent of Ag plus. That's why I put 2S under the Ag plus. Okay, the same thing, right? If it's CrO7 2 minus, your ratio is actually 1:1. Therefore, I know the concentration of the CrO7 2 minus should have a concentration of S as well. Okay? Everybody fine with this? It's very, very important. Okay. Once you can understand this, then you should see that your KSP expression in terms of solubility will become, this will be 2S squared times S first power. So you end up with 4S cubed. Okay, so can you actually write these things out yourself? Because something always being tested in your homework quiz emission. Okay, so you need to practice this type of things. Okay, so that's actually the first things that you have to get familiar with. Okay. So far, so good. Okay. But once you can overcome that barrier, you can cover. Okay. Once you know this, right, the next important thing for this chapter is actually the question you're going to be encountered will be like this. If I give you one type ions, okay, certain concentration, the other one, I use that as an example. Okay, I give you the concentration of my 80 plus, concentration of my CrO7 2 minus. If I mix them together, will I get the precipitate? Okay, so that is actually a very standard type of question that you are going to have for this chapter. Okay, so to solve that problem, then the concept that we need to have is this QSP and KSP type of thing. Again, okay. So those type of questions that always give you the information of KSP. Okay. All the things you need to do is actually you just need to know okay, how to calculate the QSP, right? But it's the same, right? Once you know the concentration, it's based in the same as how you write out your equilibrium constant. Okay, it will be your solubility of KIR to certain power times the solubility of NIR to certain power, right? Plug in the numbers given in the questions, then you get your QSP. Okay, and then you can compare that number to your KSP. Okay, and then only two possible scenarios you can have. Only two. Okay, the first one is that you have QSP larger than your KSP. Okay. Then it means you have too much NIR or KIRs, right? So it's actually far away from the equilibrium. So the thing is going to happen is that the NIR is going to collide with each other and form the precipitate. Okay? So like inside your solution, the concentration of your KIR and NIRs will stay the same as the KSP. Okay? So one possibility is that a QSP larger than KSP, then you have to see the precipitate. Okay, which I use PPT to represent the precipitate. Okay. And if the QSP is smaller than your KSP, then you will not see precipitate. Okay. So this is actually either or. Okay. If it's larger, precipitate, smaller, no precipitate. Okay. No other option is possible. These are only two options. Okay. Now later on we'll see the question there in the in your exams. They're all different kinds of crazy scenarios. Okay, but if you understand this, then you can immediately know, okay, there's actually only two options that make sense. Okay. So why don't we actually just do two questions first? Okay, the first question says the solubility of silver dichromate at a given temperature is 5 grams per 100 milliliters. Calculate the KSP at this temperature. Okay. And then it says after you calculate KSP, take the log of this to get a PKSP. Okay, so it's not important. Keyword, solubility, right? There's only one keyword for chapter 15, solubility. Okay, solubility then. Think about the things you learned in chapter 15. Okay. And then you want you to calculate the KSP, right? So the Q is to calculate the KSP. Okay. Data that you have is silver dichromate. Okay. I think right now the design of CHEM2 is actually, they will actually give you the chemical formula. Okay. Somehow I didn't update my question, so I don't have the formula here. So this is actually silver dichromate. Okay. And it says its solubility is 5 grams per 100 milliliters. Okay, and you want to calculate your KSP, right? So in order to do that, then first you need to actually write out the equation, right? Ag2CrO7 will become 2 Ag plus CrO7 2 minus. Okay. So to calculate your KSP, then you know it will be your Ag plus concentration square times your CrO7 2 minus concentration to the first power. Okay. So here, it tells you the stability of the silver dichromate is 5 gram per 100 milliliters, right? So the unit of that tells you this is a gram solubility. Okay, but every time you calculate the KSP, you cannot use gram solubility, you must use molar solubility, right? So what do? You need to convert it into molar solubility, right? So 5 gram divided by the formula weight. If you check out the formula weight of this guy, you should be able to get it from the periodic table. Okay, that's how many gram per mole. Okay, therefore to get more, you're basically doing 5 gram divided by 431.73. This will give you how many moles that you have. Okay, but for the molarity, we know the volume has to be 1 liter, right? So you know your 100 milliliters divided by 1,000, they will give you the volume in liters. Okay, so if you compute this one, then you should know that your molar solubility will be 0.116. Okay. So once you know this, okay, now it's actually an important part, right? So let's say the solubility of this one is 0.116 N. And once you reach equilibrium, what will be the concentration of your Ag plus? Then you start to pay attention to your coefficients, right? So this will be 2 times 0.116, right? So this is actually 2s, right? And then for your CrO7 2 minus will be simply 1 times 0.116, which is actually your s. Okay? Therefore, you know your KSP will equals to 2 times 0.116 squared times 0.116 first power. And then you're going to get a value of 0.0062. That's your KSP. Then to get the PKSP, then you do the negative log of 0.0062. Then you can get a value of 2.207. That's your PKSP. Okay, so this is actually the zero dot mole to solve a question like this. Okay, first thing is that keyword solubility. I think that's actually very straightforward, right? The next is actually to recognize that the formula gives you the grain solubility. You must know how to convert from the grain solubility to the molar solubility before you do any calculation. Okay. And once you know the solubility, remember it's actually solubility of your insoluble salt, right? But the things that you need is actually the concentration of your ionic species. Therefore, you should be able to write out that concentration of the ionic species based on the solubility. Okay, so once you have that, then the next is actually plug into your KSP equation to compute your KSP. Okay, so let's actually all the things that you need to know for this. Okay, any questions? You good? Okay. The next questions is this KSP, QSP type questions. Okay, so this question says the KSP of AgCl at 25 degrees C is a certain number. consider a solution that contains 1.0 times 10 to the negative 7 m of CaCl2 and 1.0 10 to the negative 3 m AgNO3. Okay, and they give you 5 different options. First one, QSP larger than KSP, precipitate will form. Okay. B, QSP larger than KSP, a precipitate will not form. C, QSP smaller than KSP, precipitate will not form. D, Q smaller than K, and precipitate will form. E, the solution is saturated. Okay. So you have 5 options, right? 5 choices. But if you have the things that we just discussed, right? There's only 2 things that will actually be true, right? If your Q larger than K, precipitate will form. If smaller than K, no precipitate. Okay, that's the only 2 answers that will make sense. Okay, so with that in mind, then you should see that the answer will either be this or this, right? So B, D, and E, that's the things that you will confuse you. Okay, but if you have correct concept, then even before you do any calculation, you know answer will either be A or C. Okay, so it's so important that you actually understand what it means by QSP and KSP. Okay, but now then, how do you actually know which one is actually true? Right. So start from the things that provide the constant. Okay, the KSP, right? So you know the AgCl become Ag plus Cl minus. The KSP is equals to Ag plus times Cl minus, both to the first power, right? And then this have a value of 1.6 times 10 to the negative 10. Okay, so the first thing is actually here to be specific equation. Okay, so try to actually write out the equation yourself. Okay, then you read the questions. The question says the solution contains this and that. Okay, so it gives you 2 solutions and it tells the concentration. The key of these 2 solutions is that each solution will contain one of the species that will participate inside your equation. Okay, let's look at the first one. CaCl2. Okay, now to think about what I'm going to get from CaCl2. Once that species dissociate, what I'm going to get? Ca2 plus 2Cl minus. Okay, so you need to actually learn how to write these things. Okay, so this becomes Ca2 plus 2Cl minus. Okay, so in this type of question, those 2 solutions, those salts, they are actually soluble salt. Okay, meaning they will dissociate 100%. Okay, so if they dissociate 100%, you can clearly see that the first species is going to contribute a concentration of Cl minus. Right? So what will be the Cl minus coming from this guy? What's the concentration? Of the soluble salt concentration, right? So you should see that the Cl minus concentration is 2 times 1.0 times 10 to the negative 7. Okay, which is 2 times 10 to the negative 7, right? Can you actually get these things yourself? That's the key. Okay. Why I write 2 times 10 to the 7 is again because the coefficients in front of your soluble salt with Cl minus is at the 1 to 2 ratio, right? But the concentration was given is actually the concentration of the soluble salt. Therefore, CO minus concentration will be double of that. Okay? So that's actually a very important step that you must know. Then, look at this guy. AgNO3, right? I hope you know it becomes Ag plus NO3 minus. Okay? And then, when you look at this too, you should notice that there's actually a guy that provides the Ag plus. Okay? Therefore, you should be able to know that the Ag plus concentration is 1 times 10 to the negative third. Okay, so this is actually a very, very standard question you're going to encounter. And I give you a KSP of insoluble salt. And I give you a concentration of 2 soluble salt. That's going to produce the ions for your insoluble salt. Okay, so you need to have the eye to see, actually calculate the proper concentration of those ionic species from the soluble salt. Okay, so once you have that, then you can put this in, right? So you are going to have 1 times 10 to the negative 3 for this, and then this will be 2 times 10 to the negative 7. Therefore, you can compute the Q, which is have the same equation here, right? Ag plus times CO minus. That's 1 times 10 to the negative 3 times 2 times 10 to the negative 7. That gives you a value of 2 times 10 to the negative 10. Right? That's your QSP. And you want to compare this value to your KSP, right? You know your KSP is this guy. Okay. Since 2 times 10 to the negative 10 is larger than 1.6 times 10 to the negative 10, therefore your Q is larger than your K. Therefore, precipitate will form. Okay. Therefore, the answer will be A. So the things that the chemistry department always want to play the trick here is that always the coefficient. For example, here we have CaCl2, right? So you can see that if you, let's actually if you recognize the concentration of CO minus will be twice of the CaCl2 concentration, then you'll be able to do this correctly. Okay, so those are the things that you have to practice. Okay, look at the chemical formula and actually predict the concentration of your ion. Okay, either NPM or NM. Those are things that you have to become a master for this chapter. Okay? Yeah, so the very last thing I want to actually go through today will be this very last one. Okay. That's a very question you're going to see in this chapter. The effect of pH are like influence the solubility of insoluble salt. Okay. So the basic idea is very simple. You start from look at the anions of the salt. Okay. So if the anion of the salt is OH minus, then when you add in the acid, then the solubility will increase. Okay. And the concept is actually very simple. Okay. So if you have insoluble salt, it produces acid, produce OH minus as anion. But adding your H plus is going to neutralize those OH minus, right? But in order to regain your equilibrium constant, you always need certain amount of OH minus. Therefore, it's going to dissolve even more. Therefore, the solubility is going to increase. Everybody follow for a second? I guess everybody's actually too tired or too excited for the spring break. We'll go through this one once we come back then. Okay, so we'll stop here today.